Okay, so this is C is the number of cilantro seeds that will grow. What is the expected value of C? How many cilantro seeds do you expect to grow if you plant them? 14. And what is the standard deviation of the number of cilantro seeds? 3. So what is the variance of the number of cilantro seeds? 9. Okay, so this is our information that we know, and our variables are defined. We would like to know, if I buy 1 pack of each, how many seeds should you expect to grow? Now, buying 1 pack of each is a new random variable. What I'm doing is I'm combining random variables. I'm taking X variable and Y variable and I'm putting them together. My X variable is the number of basil seeds. My Y variable is the number of cilantro seeds, or vice versa. It doesn't really matter which is which. Okay, so I am needing to find the expected value of basil plus cilantro. So using my formula, here's my formula, the expected value of basil plus cilantro is the expected value of the first plus the expected value of the second. It is that simple. It's very simple. If I'm going to buy basil and cilantro seeds and plant them, their combined expected value would be the expected value of basil plus the expected value of cilantro, which would be 15 plus 14, or 29 seeds. Does that make sense? Does that seem like common sense to you? It should. Expected value, I expect 15 basil and 14 cilantro. I expect 29 seeds to grow if I plant 1 pack of each. The thing that might not go so well is the variance part, okay? But wouldn't you expect more variance, different kinds of seeds, more variability in how many are going to grow, okay? So the way, now I want to find the standard deviation of basil plus cilantro, but what I'm going to do instead, I'm going to find the variance of basil plus cilantro, and then at the end take the square root of it. It will make your life easier in the long run, I promise, if you just deal with variance. And the formula is basically here. This is the formula. The variance of x plus or minus y is always the variance of x plus the variance of y. And then if you want the standard deviation, you just take the square root of that. The standard deviation of x plus y is the square root of the variance of x plus or minus y. Okay, so you do this formula, then you take the square root of it. It's that simple. That's how you get standard deviation. All right, so the variance of B plus the variance of C, or the variance of B plus C is the variance of basil plus the variance of cilantro. What's the variance of basil? 4. And the variance of cilantro? 9. So that would be 13. So the standard deviation of B plus C is the square root of 13. You just take the square root of the variance. That's all it is. Standard deviation is the square root of the variance. Variance is the standard deviation squared, which would be approximately 3.61 seeds. Okay. All right, so if you buy 1 pack of each, what is the expected difference in the number of seeds that will grow? What is the standard deviation? Okay, so this time, we've still got all of our same given information from right up here. All of that's still the same. So we just want to know, if you buy 1 pack of each, what is the expected value of the difference in the number of seeds that will grow? So that would be the expected value of B minus C, right? Could I do C minus B? Yes, you could. That would be fine. Okay, we'll just do B minus C. That would be the expected value of B minus the expected value of number of cilantro seeds. Where does that come from? That comes from this formula. When it's minus, you subtract the expected values. Okay? Expected values do exactly what you would do when you combine the random variables. If you're adding them, they add. If you're subtracting them, they subtract. So the expected value of basil was 15. The expected value of cilantro is 14. So what's the expected difference in the number of seeds between the 2 packs? 1 seed. Does that make sense? It should. There was 1 seed difference that they expected to grow. Okay, so now I want to find the standard deviation, but first I find the variance. So the variance of B minus C, and here's where you have to look at the formula again. If you subtract, what do you actually do? What does it say in the formula? You add. Whether you add or subtract, the formula says you add. Variances always add. More variables means more variability. The more things you plant, the more chance you have of things not growing. So that would be the variance of B, basil, plus the variance of cilantro. Well, the variance of basil was what? The variance of cilantro was 9, so the variance is 13. So the standard deviation of basil minus cilantro is the square root of 13. All you do to go from variance to standard deviation is take the square root. It's that simple. Which is that, so basically it's the same standard deviation regardless of whether you're finding the sum or the difference. If I'm adding them, wanting to know the total combined, it's 29 seeds, give or take 3.6 seeds. If I'm finding their difference, it's 1 seed, give or take 3.6 seeds. You still have the same amount of variability whether you're adding or subtracting because you're combining things. All right, so now what happens if I buy 3 packs of basil seeds? Okay, now this is like adding 3 random variables. So this would be the expected value of basil plus basil plus basil. So all we're doing is using this same formula, but instead of just x plus y, we have x plus y plus z. We're just adding 3 things. The same thing, this applies whether you have 2 or 3 random variables. So this would just be the expected value of basil plus the expected value of basil plus the expected value of basil, which would be 15 plus 15 plus 15, or you plant 3 packs, how many seeds do you expect to grow? 45. Does that make sense? You'd expect 45 seeds to grow if you bought 3 packs, and each pack was expected to have 15. Okay. All right, so now we need to find the standard deviation, or the variance of basil plus basil plus basil. So that's going to give us, well, let's see, that's just the variance of basil plus the variance of basil plus the variance of basil. Well, what was the variance of the number of basil seeds that would grow? 4. So this would be 4 plus 4 plus 4, or 12. And so what's the standard deviation of basil plus basil plus basil? What do you do with the 12? Square root it. And so that would be equal to 3.46 seeds. So if I planted 3 packs of basil seeds, I would expect 45 to grow, give or take 3.5 seeds approximately. Okay, again, all I'm using are these 2 formulas right here, and the fact that standard deviation is the square root of variance, which I do last. Okay, so the last one, now I'm going to buy 3 packs of basil and 2 packs of cilantro. Well, so isn't the 3 packs of basil something I just did? Okay, so, I mean, essentially I'm just taking the expected value of basil plus basil plus basil plus what? Just that, right? Just adding a bunch of them. So basically you're just taking and adding the expected value of basil how many times? And the expected value of cilantro? Twice. So 15 plus 15 plus 15 plus 14 plus 14 is, how many seeds are you going to expect to grow? 70, how? 70, 73? I don't know. 73?
Yeah.
Okay, so 73 seeds you'd expect to grow. And that expected value thing should be just common sense when you're just combining them. If I expect each pack to grow this, I add them all up, and that's how many I expect to grow. Okay, the variance, though, this should have a higher variance than the last one, okay, because we're adding different kinds of seeds. We're adding 2 more packs. So the variance of basil plus basil plus basil plus cilantro, basically we're just going to take and add the 3 variances from before, which was 4 plus 4 plus 4 plus 2 more variances. What was the variance of cilantro? 9. So 9 plus 9. So that's 12, 30. That's the variance. So what's the standard deviation of basil plus basil plus basil plus cilantro plus cilantro? What do you do to 30? Square root it. And that is equal to 5.48 seeds. So do you see how that created more variability by adding those two? Because this standard deviation is higher than this one. So your homework's going to deal with things like this. You've got the odd problems in the homework are over this new stuff that we talked about. These even problems are just more finding expected value and probability distributions. So this 37 isn't due until the day of the semester test. I'll let you use it on the test. So it's kind of like you get a big old cheat sheet or something for the, that you can you'll have all the answers too. It's like I'm just giving you a gift of notes to use in points. So there you go, if you do it right. All right.